This is a project about Titanic dataset. This is a project that we use machine learning to create a model that predicts which passengers survived the Titanic ship wreck.
Okay, so first of all, we will import the libraries in our Python code, and we will add some algorithms that we will perform some functions in our Python code. So after it, we will check the explainability of our code functions, like we will loading the data and getting the informations about some column values. So after it, we will check the some missing values and we'll see that there are some missing values, like we have some missing values in age, cabin, and bulk values, like there are 50 missing values in each column. So cabin, after that we will values through drop the cabin values, because there are lot of missing values in cabin, and we will drop it because if we will not drop it, that will not give our true values. We will replace the embarked values by mode, because our data set is integers, because our data set is string, not an integers. And we will also some replacing the missing values, like we will replace here, and further we will check the missing values. If there is any missing values, then we will replace it. If there is no missing values, then no need to perform any further functions. After that, we will perform the function data analysis, because for numerical data values, we have age and the figures are only rooms, and therefore if we will directly analyze it, then it will not give a meaningful values. At the end, we will visualize our data sets, and we will plot some dots in between survival values and their sexual orientation values. And we will see that zeros are not survived and ones are survived. We will also perform some function on sex values, like we have up to 500 males, and blue one 500 males, and the pink one are up to 300 we have females. And we will also plot some more values on sex orientations in between zeros and 250s. And we have blue one male values that are 250, and females values are up to 150s. And we will perform these values through count functions.
Number of people in
I think
each
that
class for train data will be
Demi has an internet
visualized
issue.
with the class one being 210 people, class two 190, then class three 490. Then the next one is the number of people in each class for test data, with class one having 110, class two having 90, and class three having 230. So the next one is number of people that survived in each class for train data. So 7 people died in class one while 130 survived. 100 people died in class two while 80 survived. 370 people died in class three while 120 survived. So next one, number of people that survived in each class for test data. 55 people died in class one while 50 survived. 61 people died in class two while 30 survived. 150 people died in class three while 70 survived. So the next one is encoding the categorical colon. So in the train data sets, we have a total of 577 male, 314 female, Then we have the name, which is name, sex, the data type, and the int 64. Then the test data set also, where we have male as total of 266, female 152, name, then you have sex, data type, and int 64. Then we also have the train data set of those number of people embarked, and also the test data set for those number of people embarked. So you're having S as for the train data set, you're having S as 646, C as 168, Q as 77. Then for the test data set, we're having S as 270, C as 102, and Q as 46 rather. So so we're gonna be converting categorical columns. So train data set, you having sex, male will be converted into integers, female also integers. Then the embark value also, S will be converted to integer 0, then C will be converted to 1, and Q will be converted to 2. That is also going to be applied to applicable rather uh, to the test data set, where male will also be 0, female 1, embarked also, S is going to be 0, C is going to be 1, Q is going to be 2. So then we're going to have a separating features and target. So the X string represents our features, which are the passenger ID, name, ticket, and survived. So the Y train represents the target, which is the number of people rather, that survive.
Since we are working with a categorical data, we decided to use logistic regression for our model as our model. We trained the model using our S train and Y train. Then we checked for the training accuracy, which we got an 80% for the accuracy. Then we did a model evaluation using our S test. Then we actually got an accuracy of 94. Then we used the decision tree classifier model. We trained our model, then checked for the training accuracy, which we got at 98 degree. Then we did a model evaluation using the S test, and we got an accuracy of 78 degree, 78%. Then we used a Gaussian naive Bayes model. We trained our model, did a prediction on it. Then we actually checked for the training accuracy. We got 79%. Then we did a model evaluation. Our model evaluation, we got 92%. Then we use random forest classifier. We got a training accuracy of 98 degree, 98%. Then with our model evaluation, we actually got 80%. Then we use a deep learning model also, which is the multi-layer perception. We trained our model, then made a prediction with it. We got a training accuracy of 81. Then with our model evaluation, we got a 83% accuracy. Then we compare the accuracy of all our 5 different model. Logistic regression are the best at 94%, which is 0.94.
These
Being
models are
a
just black box models and do
local
not give an
interpreter,
insight
we are
to how
taking
exactly they
of
come
the
about this
data and we'll
accuracy.
be
So
explaining
for
based on that
explainability, we use the LIME,
of our
which is a
model.
local
So in the logistic regression,
interpretable model
the model
agnostics
is
explanation.
66% confident
Model
that the
agnostics
person
being that
died
it
and
is
having
able
a
to
34%
be applied on any
confidence of
machine learning model,
survival.
which is
And
suitable for our
this
case where we have 5
percentages,
different machine
the
learning
death
models.
is
So
due
we
to
use the
the person
explainer,
having
which is LIME, and
been
we
on
apply it on all 5
been on class between
models
second
to
and third,
determine, to give an
being above the
explanation
age of
as to why
35,
an
embarked
individual
at
on
point
the
zero
Titanic
point zero,
either
have more
died
than
or
between 0 and
survived.
1 sibling, and appeal
And
a fare
being
of
a
less than
local
7.9.
interpreter,
And
it
what
just takes
reduces, what
a small
opposes this
area
is
and gives an
sex
explanation
from
based on that.
0.48 and number of parents being 0.02. Moving on to the next, which is decision tree. The model is 100% post confident, sorry, that the person died. And this is because of the class um, contributed 0.14 to that, the age contributed 0.13, and embankment contributed 0.04, and fair as well 0.04. While chances of survival are so low, we have 0.54 for sex, 0.07 for number of parents, and 0.04 for number of siblings. For Gaussian naive bias, the model is 39% confident of person on the first row dying and 61% confident that the person survived. And this percentage of survival is, is contributed by 0.53 um, for the sex, 0.03 for number of siblings, and 0.00 for number of parents. It says that this person doesn't have any parents, so he's not responsible for anybody, so the person is able to run for survival. This actually contributes greatly to the survival of the person. While what could have contributed to the person's death is paying a fee of less than 7.91, having between 2 and being between second class and third class embarked at point zero, and being above the age of 35. Moving on to the multi-layer perceptron, the model is 60% confident that this person on row one died, and this is because this is because he or she paid a fare of less than 7.9, which contributes to 0.18, wasn't between class 2 and 3, we contribute 0.11, above the age of 35, we contribute 0.11 as well. Having between 0 and 1 sibling, we contribute 0.04, and embarked at less than zero point 0, which contributes 0.03. And what opposes that, saying that the person could have survived for sex, is 0.46, and number of parents 0.08. Finally, on to the random forest. The model is 72% confident of death and 28% confident of survival. And what contributes to survival is just 0.38 for sex, while other features contribute to the percentage confidence that the person died. Comparing all five models, you can see a trend for this personal row one. Only the Gaussian naive bias predicted the person survived, while all other models had above 50% prediction that the person died. Thank you.